All right, so let's jump right in. We're about to explore this really wild, unlikely story of how some of the most advanced AI on the planet is being put to work. But not in some shiny, sterile lab. Nope. It's being deployed in the gritty, chaotic world of construction waste. It's this incredible tale of turning literal physical trash into what you could call digital gold. And this quote, man, it just nails the whole thing, doesn't it? Because if you read the technical documents for this project, you'd swear you were looking at a hot new fintech startup. But then you look at where this is all happening, and you're basically standing in a dump. We're talking mud, busted up pallets, demolition debris, and that huge gap between the high-tech and the harsh reality, well, that's exactly where the opportunity is.
Okay, so before we can really get into the solution, we need to understand the problem that a company called 905 Wood is tackling. And they've given it a name that, I gotta say, sounds like it's straight out of a sci-fi movie, data anarchy.
And this definition really gets to the heart of it. I mean, just picture this for a second. You're trying to run a modern, efficient supply chain, but all your records are just crumpled, handwritten receipts stuffed into a shoebox. That's pretty much been the status quo for construction waste. You've got no reliable paper trail, no verifiable chain of custody. And what does that lead to? Massive inefficiency and, you guessed it, a ton of legal liability. So, how do you fight that kind of chaos? Well, 905 Wood's approach was really smart. They didn't start with a massive cloud server somewhere. Nope, they went right to the source of the problem, with this really rugged piece of hardware they call the industrial edge node. Let's see how this thing works.
And here's the big aha moment. The intelligence, the brain of the operation, can't be miles away in some data center. It has to be right there, on the truck, at the demolition site. You know, places where you might have terrible internet or maybe none at all. That whole idea is called edge computing, doing the processing right where the action is. And honestly, it's the key to making this entire system work.
And the hero of this story, believe it or not, is a smartphone. But we have to completely throw out our idea of what a phone is for. In this system, the Google Pixel 10 Pro isn't for scrolling through social media or making calls. It's been transformed into this tough-as-nails industrial tool, an inference server, which is really just a fancy way of saying it's a portable AI brain that can run complex models all by itself right in the palm of a driver's hand.
Now, you can't just do this with any old phone. This transformation is only possible because of some very specific tech packed inside. You've got Google's custom Tensor G5 chip, which is designed to handle the heat, so it can run intense AI scans for a full 8-hour shift without melting. The dedicated AI hardware, the NPU, means it can process everything right on the device. This is what enables offline first workflows, meaning it doesn't need an internet connection to do its most important job. And it's all running on the new Android 16 operating system, built for exactly these kinds of demanding tasks.
And listen, this isn't just some marketing fluff. What you're looking at here is a page straight from the project's official technical integration report. It says it right there in black and white. The Pixel 10 Pro is being used not as a consumer smartphone, but as a distributed inference server built for harsh industrial environments. This is the real deal. This is where the rubber, quite literally, meets the road. Okay, so we have the hardware, but how does that one piece fit into the whole puzzle? Let's walk through the step-by-step anatomy of this digital refinery and see exactly how it turns a physical stream of waste into a high-fidelity stream of data. You know, the workflow itself is actually beautifully simple. It all kicks off with a digital request for a quote. Step 2, the driver is on site, and the phone's AI scans and verifies the wood right then and there. That data is then instantly mapped against complex government rules, like Ontario Regulation 347. And the final step, the system automatically generates a verifiable certificate. Done.
So let's zoom in on that on-site triage step, because it's really the core of the whole thing. It's powered by this super optimized AI model called EfficientNet B0, running on the LightArt AI stack. The model has been quantized, which is just a technical way of saying they've cleverly shrunk it down to be small and fast enough to run right on the phone's chip. And this allows it to instantly tell the difference between clean, recyclable wood and that potentially hazardous, treated wood.
And when I say instantly, I really mean it. The classification happens in under 2 seconds. Now, this isn't just about being fast for the sake of being fast. In logistics, time is everything. If a driver has to stand around and wait for even 5 extra seconds at every stop, compliance rates plummet, and the entire system gets bogged down. That sub-2-second triage isn't a luxury, it's a logistical necessity.
So, we've scanned the physical waste with this lightning-fast AI. What comes out the other end? Well, this is where the real alchemy happens. This is where you turn a physical liability into a truly valuable digital asset.
And here it is, the result. A perfect, verifiable chain of custody. That data anarchy we were talking about before, it's gone. Vanished. Replaced by a clean, auditable digital trail for every single piece of wood that enters the system.
The final product you get is this, a digital diversion certificate. Yeah, it's an auto-generated PDF, but it's a PDF that is absolutely packed with proof. It has the GPS coordinates from where the wood was picked up, the AI's verified analysis of what it's made of, and a record of its final destination. It totally transforms waste from a liability you have to pay to get rid of into a certified asset with documented value.
But this is bigger than just one company or a clever app. This technology is serving a much larger strategic purpose. It's acting as what the project calls Ontario's Biocarbon Bridge.
That sentient bridge metaphor is just so powerful. Think about it. On one side of the bridge, you've got chaotic, messy construction sites. And on the other side, you have this emerging biocarbon market, an industry that can create valuable materials like biocharcoal. But, and this is a big but, it needs incredibly pure, clean feedstock to do it. This digital refinery is the intelligent, the sentient connection that makes that link possible for the very first time.
This really lays out the end game. By creating this verified, high-purity feedstock, 905 Wood isn't just cleaning up waste, it's literally enabling a whole new industry. It's using AI to secure Ontario's leadership role in the global circular bioeconomy, and it's turning what used to be a complex regulatory burden into a major competitive advantage.
And that leaves us with a fascinating question to chew on. We've just seen how this combination of rugged hardware and sophisticated AI can bring order to the chaos of construction waste. So, what's next? Think about agriculture, or textile recycling, or e-waste. What other industries are just drowning in their own kind of data anarchy, just waiting for their own digital refinery to be built?